So hi everybody, today we're going to talk about resistors, and current. So let's start with the first question. So do you have any collection of something? I collect coins, and the same guy in the question also collect coins, and he decided to go to the book of Guinness and try to build the highest pillars of coins that ever been built. So he puts coin on coin on coin, and he called to Guinness book and asked them to bring someone to check this magnificent pillar and check if this is actually the highest. Let's do this as a z-axis, the highest building of coins in the world. This is L, the height of the. And he came to check it, and he said, dude, it's a little bit problematic to check the height of the building, since most of people put this building on top of something that can weight the building, and then you can say, oh, this is the weight, I know how many coins there are. And another way is to put here some to stand on high place and throw away some length and mark where is the length of the building, and then check what is this rope, what is the length of this rope. But there's no space so high above this pillar, and he said, okay, what can I do? And then he came up with the idea when he called Guinness engineers, and they said, it's really simple. Take some wire, here's some wire, and connect it to the top of the pillar, and another one connected to the bottom of the pillar, and put a battery between them of some volt, V0, and we know what is the resistivity. I know it's confusing, it's not charge density, it's resistivity. I know it's the same letter. So resistivity, as you saw in the lecture, which is, for this specific problem, this specific pillar, is rho 0 z to the 5 divided by what we actually want to find, L, okay, the length, to the 5. This is a given data. So that's our goal. Okay, but before we're gonna start doing this and find what is the length of the building, I want to ask you, what is the resistance of each coin? You see, for example, this coin. What is the resistance of each coin? So let's put here, let's divide it. What is the resistance of a single coin? Okay, let's try to do this. So I'm gonna note the coin with dr, because it's really small resistance. You know, this is a huge pillar, so dr. And the formula for resistance, I'm gonna write it in blue, which is really important, is R equal to, and I have a method to remember it. It's a stupid method, but it's worked for me. You can use it if you want. So I think about resistance as something said, you know, want to resist you, so it's a said person resistance. So I do like one eye here, and you see that I have a said smiley. This is my method. And then I complete this one to be A, which is area, this one to be resistivity, and this one to be L, the length. Let me do it a better eye. L, the length. So this is my method to remember what is the resistance. So in our case, if I come into the coin, this is the current, right? The current coming from that direction to that direction. So what is this distance? If it's a really small length, I can call it dz, right? Makes sense. So here we're gonna put dz. The resistivity I already know, and it's depend on z. So each dr is actually function of z. The coin are not equal for some reason. And A is the area that the current see when it's coming to the coin. If here, perfect. So here, if there is a coin and I'm the current and I want to come into the coin, what is the area that I'm actually seeing? This one. So if we're talking about coins, so it's a circle, right? So it's pi and some radius, let's call it a square. So the radius is a, okay, given, perfect. So now we can actually calculate what is the resistance. So what is the resistance? We just need to put the numbers. So we're getting dr is a function of z, and this is equal to this thing, which is rho 0, z to the 5, L to the 5th. We have this a, which is pi a squared, and multiplied by the length, which is the z. Perfect. Okay, so we found what is dr. And now I'm going to ask you, what is the total resistance of all this magnificent coin pillar? Okay, so to find that one, we can this out. What is, before that, let's do something else. Let's ask how the resistors are connected to each other. It's even a better question. How does the coins connect to each other? Okay, so there's two options, right? You can do it in series, right? It can be like this, okay, sharing the voltage, and they can be like kings. Sorry, fighting for the voltage, and here sharing the voltage, which is parallel. Which way we are looking at, parallel or in series? So let's look at the coins. So if this is the current, is coming this coin touching one side of the battery, and then he touch another one, and then the last coin actually touching the battery. So do you see that we actually living in that case? Why so? So this is the battery, and now I touching only the first coin, and the first coin touching another coin, and this going on until the last resistors touching the battery. You see it? So in our case, we actually have resistance in series, which means this is the voltage, and each one of the coins wants a little bit for himself. They don't want to share it. They want each one to fight. No, give me the voltage, right? That's what they want to do. If we had this configuration, actually all the resistance were peaceful and happy and have the same voltage across all the resistors. So this is the case in our solution. So if we want to calculate what is the total resistance, let's do it. So let's clean this part. What can I do? Okay. So what is, next question, what is the total resistance, our total resistance? So we know how to calculate resistance in series, which is really easy. It's R total equal to sum all the resistors. That's all. That's all. All we need to do, okay? So, and I want you to notice that this is the opposite of capacitors. In capacitor, if you remember, a trick to remember, in capacitor, this is a series. Let's do it like this. Okay? Total, in capacitor it was the opposite, right? It was equal to the sum of 1 over Ci, and this was a -1. So if you want a method to remember it's always the opposite of capacitors. That's how I remember it. Okay? So let's sum all our capacitors. So our total is actually equal to what? To the sum of all the dr, right? All the resistors. But if I have a lot of resistors and a lot of coins, this guy want to break Guinness, right? Guinness record. So we actually have a lot, so we can change this sigma to an integral. So integral of dr. And what is dr? We already found it in the previous section. So it's actually an integral on this is the resistivity 5 pi a square z to the 5 dz. So this guy is a constant, it can go outside. And what are the limits of my integral? which is the lowest Z value that I have and which is the highest Z value. So of course, we're talking about starting with height 0, and the final one is what is the size of my structure, of my pillar. So if I'm gonna do the integral, which is really easy integral because it's a polynomial, so Z to the 6 divided by 6, we're getting rho 0, L divided by pi a squared 6. Perfect. So we found this one. Let's continue to the next question, which is what is the length? Remember, that's what we want to do. So they told me that they add to the circuit ampere meter, what is ampere meter? Ampere meter, if this is the coins, right, and this is the batteries, so they put here some device that measure amperes. Meter is to measure, ampere is the unit of a current, so I actually know what is the current that I have here and here, right? I have the current, I have the voltage, and to find what is the length, I can use some famous formula, which is Ohm's law. Ohm's law states that the voltage equal to the current multiplied by the resistance in the circuit. Okay, how I remember this formula? Try to read it, how it sounds, VIR, right? VIR sound to me like beer. So another stupid method to remember stuff, which is really help in the first week and then you remember it by heart, but it saves time. So V equal IR, VIR, I think always as a beer. And there's another analogy that you can use if you want, that beer actually present really well the law itself. If I have a beer, for example, let's put it in that way. So here I have some weight of some energy, some potential, some weight of liquid. So this build a tension, a pressure difference, right? A pressure difference because of the height here in this point. So there's a lot of pressure here. So there's some current that go outside, right? This is the current that go outside of the beer. If I had a bigger beer, right, more, so I had more voltage, right? That's what would happen, and I would have more current, right? Because I have more. Or maybe I can just hold this part here and squeeze it, and then the current also would be significant. You're gonna magnify. Why? Because I changed the potential, right? Put more force to it. And what is the resistor in this picture? The resistor is actually the opening, which is depending on rho is a R. This is the opening, is actually the resistor, which is equal to A rho L. So I have here some geometry. If I have like a really small, really tiny here, tiny opening, so the current will be low, okay, which means I have a huge resistivity since of the geometry, A and the L. And if I have different material here, okay, let's do an example. If I have here like this opening, so boom, all the water will fall immediately. There will be almost non-resistance due to geometry. So this is the difference between this kind of geometry, this kind of geometry, okay? And also the material. If the material of the opening gonna be some filter or stuff like that, so something that some net or something, so also can change resistivity. It's another day you can play with this analogy a little bit, but I want you to remember beside beer that you have VIR, which is Ohm's law. Okay, Ohm's law. Perfect. Okay, so I can use Ohm's law since I know V0, I know I0, and I know the total resistivity, resistance, which is rho 0 L pi a squared 6. I can actually find out what is L, the length. So what is L? L is equal to V0 divided by I0 multiplied by pi a 6 divided by rho 0. So we found the length, and now they can check if the guy won his Guinness prize. So that was the first section of this question. Now let's continue to the next part.